take a look at our last section for the week, which is 2.1. And this is on a little bit more that we touched on at the end of class yesterday, zeros, okay, finding zeros of functions. So one thing I'm going to show you how to do is use the calculator to find a zero. Okay, so we'll look at that. So let's just start by graphing that. Okay, so that is what we call a polynomial. Specifically, the highest exponent is a 3. Okay, that makes it a cubic polynomial. Or you could say degree 3. All right. That 3 is important. Okay, so I'm going to talk a little bit more about what that 3 tells you, okay, in a minute. Let's go to y equals, and we'll type in 2x. The exponent button is right below the clear sign above the division. And then once you press that and do an exponent of 3, you need to press the right arrow to get out of the exponent, because I have more to type that's not an exponent. So minus 3x squared minus 3x plus 2. Now, when I hit graph, is this one going to be a parabola? No. To be a parabola, it wouldn't be able to have that exponent of 3. Okay, the highest exponent a parabola can have is a 2. Okay. This has a 3, which means it might have a little bit more going on than just a parabola. Okay, so I'm going to do zoom 6. And yeah, that's a good window. And let's take a look at that. So the highest exponent that we had in that equation was a 3. If you subtract 1 from the highest exponent, that tells you how many times the graph could turn. That's what that highest exponent tells you. If you subtract 1 from it, it's how many times it could turn. So highest exponent's a 3. Subtract 1 from it, you get a 2. That means this graph could turn 2 times, and it does. It turns here, and then it turns again right there. Not everything with an exponent of 3 will turn 2 times. Here's one. If I graph it, it never really turns. Okay? If you zoom in, you could see it a little bit better. But it kind of is going up. It flattens out a little bit like it wants to turn, but it never does. Okay? So just because something has an exponent of 3 doesn't guarantee it's going to turn 2 times. But it could turn up to 2 times. Okay. So let me get rid of that red one. We don't need that. Okay. Any question on that idea about turning? Now, the other thing that 3 goes along with is how many times the graph could cross the x-axis. Okay, we go back to this one. The blue graph had an exponent of 3, and it crossed 1, 2, 3 times. So it crosses 3 times. The red one also had an exponent of 3, but it only crossed 1 time. Okay. So that exponent can tell you a couple different things. So the one that we just looked at, the blue one, it crossed the x-axis 3 times. When you have a point on the x-axis, anywhere, any point on the x-axis, what is the y value? It's always a 0. Yes. That's why we call the 3 places where this graph crosses the x-axis the zeros. There's a 0 on the left, there's one in the middle, and there's one on the right. Okay, and I used that term yesterday at the very end of the lesson when I looked at parabolas, and I said, how many zeros does the graph have? And we had a formula, b squared minus 4ac, that could figure it out. With a cubic, we don't learn quite as simple of a trick to figure it out. With a cubic, we generally have to graph it. And then we can look at the picture. All right. I want to show that what I have written right there with 3 sets of parentheses is exactly the same as what's up above. Besides graphing this, okay, I could graph this and see if it's right on top of the other one I already graphed. I could do that. What else could I do with this to show that it's the same thing as what's up above? Yep. Yeah, let's distribute it out and see if we get 2x cubed minus 3x squared minus 3x plus 2. When we distribute it, we have to do 2 sets of parentheses at a time. We're going to forget about the third one for now. Okay, so let's do these 2. All right, so if I multiply x times 2x, what does that give me? Yep, 2x squared. Good. How about x times negative 1? Negative 1x, I'm just going to put that off to the side for a minute. And what about 1 times 2x? So negative 1x plus 2x is a positive 1x. And lastly, 1 times negative 1 gives me negative 1. So that's what you get when you multiply the first 2 together. Now we're going to multiply that times the last one. So we're going to distribute one more time. So we'll start with x times 2x squared. And Quinn, what's x times 2x squared going to give me?
2x cubed.
Yep, 2x cubed. Okay, next one. Let's do x times x. Madison, what's that?
2x.
So that would be x plus x. That's x squared. And then we have to do x times negative 1. Ruben, what's that?
X times negative 1.
Yep.
Negative 1x.
Negative 1x. And now let's do the negative 2. So negative 2 times 2x squared gives me how much?
Negative 4x squared.
Yep, negative 4x squared. Negative 2 times x, negative 2x. And what about negative 2 times negative 1? 2. So let's combine all that together and see if it comes out the same as what's up above. So you got 2x cubed. We've got 1x squared, take away 4x squared.
Negative 3x squared.
Negative 3x squared, so we got those. What's negative 1x? Take away 2x.
Negative 3x.
That's negative 3x. So the only thing is the plus 2. Okay. And if we look at what we originally had up above, it's exactly the same thing. Okay. So any question why this is the same as that? Now, if you wanted to figure out where it crosses the x-axis, which one of those do you think is better to use? I mean, they're the same, but one of them is a lot easier.
3x.
Which one?
Oh, sorry, do one.
So the top, would it, if you wanted to figure out where it crossed the x-axis, do you think the top one's better or the bottom one? Yeah, the bottom one is going to be a lot better. Okay. Let's see if we can use that bottom one to figure out where the graph crosses the x-axis. Okay. So if you want to find out where something crosses the x-axis, you set it equal to 0. That's how you do it. So let's set it equal to 0. And I'm going to use this one, not the top one. X plus 1, 2x minus 1, x minus 2, and I'm going to set it equal to 0. Okay, so for a second, just forget about what's actually inside those parentheses. Okay, pretend like you can't even see what's in there. You've got something times something times something, and it's going to give you 0. What has to happen? If you're going to multiply 3 things together and get an answer of 0, then you know something. Yeah? One of them's got to be 0. It's the only way you can multiply 3 things together and get 0. Doesn't matter what's under those boxes. Okay? Either what is in the first parenthesis has to equal 0, or what's in the second parenthesis has to equal 0, or what's in the third parenthesis has to equal 0. So there's 3 different answers you could get. What could you plug in for x to make that one? Yep, -1. What could you plug in for x to make that one 0? Yep, 1/2. And what could you plug in for x to make that last one 0? 2. Let's take a look at the graph again. Let me zoom in a little bit, and let's see if those numbers look right. Let's set our x min at -5 and x max at +5. Let's take that picture. And where does it look like that graph crosses the x-axis?
1, half, and 2.
Yeah, crosses exactly at those numbers. -1, there's that one. 1/2, there's that one. And 2, there's that. Those 3 numbers wouldn't have been as easy to figure out if you weren't able to take this and rewrite it like that. So the goal of this lesson isn't to figure out how to rewrite it like that. We'll talk about that more later on. But I just wanted to show you the advantage of writing it like that. Okay. So those 3 numbers that we just have, what were they again? -1, 1/2, and 2. Those numbers are called the roots of the equation, or you also could call them the zeros. So this particular problem had 3 of them. If you want to think about them in a more visual kind of way, you could also call them x-intercepts. When you write a root or a 0, you can just write a single number. Right? So these 2 things, you could just write a number. But if you're describing something as an x-intercept, a lot of times they're going to ask for it as a coordinate. All right, so if I asked you, what are the x-intercepts for that last problem, you would say -1, 0, 1/2, 0, 2, 0. Those are the x-intercepts. The roots are -1, 1/2, and 2. And you'll see the word root or 0 used interchangeably. On our calculators, when you go to the calculate menu, there's an option to do what we're learning today. I want to show you how to use that option. I don't think we've done option 2 yet, have we? If you use an older calculator, or maybe a different brand, some of them do say root instead of 0, but they're synonyms. Okay, same thing. All right, so that's a cubic. Okay, cubic can be a little more complicated because it could have up to 3 different answers. Let's kind of step back for a minute and just look at something a little simpler, a linear equation. If you draw a line that's not horizontal, horizontal could be a special case, any kind of line that's not horizontal, how many times will it cross the x-axis? How many? Yeah, it can only cross 1 time. Right? A line that's not horizontal can only cross 1 time. If you had something that looked like that, what would be your 2 steps to get x by itself?
Subtract b and divide by a.
Subtract the b, so the b would become negative, and then divide by a. So to solve something that looks like this, I could teach somebody how to get the roots of that equation without understanding any algebra. Okay? We know algebraically you have to subtract 4 and divide by 3. But I could just show them this formula. And even if they don't understand algebra, I could just say, take the opposite of that number and divide by that number. They might not understand why, but it would work. That's how you always can find the roots of a linear equation. It's the opposite of this number, and then you divide by that number. So what I've just shown you here, this is kind of like the quadratic equation, but it's a lot simpler because it's for a line. Okay? So it's showing you how to get x by itself in a linear equation. So let's look at this one. 2x plus 3 equals 0. And again, even if you didn't understand algebra, but you know which number is a and which number is b, you can just plug them into that formula, and it would give you the answer. So what would be the answer for x in this case? Right. It's the opposite of this number divided by that number. And could this, since this is linear, could it ever cross the x-axis again at another spot? No. Linear means it's just straight, right? It can't curve and cross again. Okay, so linear is the simplest case when you're asked to find the roots or the zeros or the x-intercepts. So the next step up from linear is a polynomial of degree 2. What's the name that we use for a second degree polynomial? So that has to do with how many terms are in it. Yeah, this is a quadratic. Okay, so specifically, this on the board is a trinomial because it has 1, 2, 3 terms. And what kind of trinomial is it? It's a quadratic because the highest exponent is a 2. How many times can a quadratic equation cross, when you draw it, cross the x-axis? Yeah?
2 times.
2 times? Or?
Once or none.
Once or none, right? So we talked about yesterday how the discriminant can tell you that. But the discriminant is, that's b squared minus 4ac. That's the name of that part of the quadratic formula. And does anybody remember, I didn't want to have to go through the whole thing again, but can anybody tell me how does the b squared minus 4ac quickly tell you how many times it can cross the axis? Yep.
It's like -1 or less is 0 or something along those lines. I have it written down. I don't have it written down.
Anyone help us out? Yep.
If it's less than 0, then there's no 0.
Okay, so if this comes out less than 0, never crosses the x-axis.
And if it equals 0, then there's 1 0.
Yep. If it's equal to 0, it crosses 1 time. There's one 0 or 1 root.
If it's greater than 0, there's 2 zeros.
Yep. And if this calculation comes out to a positive number, then it'll cross the x-axis twice. Go out 2 roots, 2 zeros. Okay. So let's solve this one. And it says to solve approximately. When it says approximately, a decimal is okay. Right? So I think we'll do it as a decimal, but then we'll review quadratic formula because that's also going to be on the test as well. All right. Whether you're going to solve this problem graphically which is the way we're going to do it, or if you were going to use quadratic formula, you want to get it equal to something first. Anybody remember what?
0.
Yeah, we want to get it equal to 0. And we also want to try to keep this as a positive. Right? So that means I would take everything on the right and move it to the left. How are we going to move the 2x over to the left?
Make it positive.
Yep, we're going to add the 2x and the 1, subtract it. Okay. So now we're ready to solve it. All right, so let's put that in on the calculator. So we got 2x squared plus 2x minus 1. Now, because the highest exponent is a 2, we know it's a parabola, and we're looking to see if it crosses twice. Okay. If it does, we've got to give both answers. If we can't see the whole parabola on the screen, we might have to zoom out till we find it. But I'll start with zoom 6. And this time, zoom 6 is perfect. Okay, I can definitely see the whole parabola. That's a complete graph. Didn't cut anything off. And I want to find these two intersections. Now, just so it's easier for you to see, I can see it fine, but I do want to zoom in. You don't have to on yours. Just if you're sitting in the back, I want people to see it better. Okay, so I'm going to calculate the zeros. That's why I set it equal to 0 when I started the problem. So to calculate a 0, press second, trace, and the second option down is 0. Okay. Like a lot of the things in this menu, it's going to ask you 3 questions when you pick option 2. The first thing it says is left bound. Left bound means you need to move your cursor until you are to the left of the 0 you're trying to find. We're going to have to do this twice because I can only find one at a time. So I'm going to put my cursor to the left of one of my zeros. I'm going to hit enter. And then I'm going to move my cursor so that it's definitely to the right of one of my zeros. And I'm going to hit enter again. What I've given the calculator now is kind of an interval to look at. The guess doesn't really matter. Hit enter, and I get negative 1.37. Okay, if we round it. Okay, and that's our first 0. Okay, second 0. Repeat the same thing, except this time, focus on the one on the right. So second calc, 0. Move your cursor till it's somewhere to the left. It doesn't have to be too close, it's just somewhere to the left. And somewhere to the right. So now it's got that interval it's going to look in. And again, the guess, you can put it close, but it's not going to really matter. The other answer is 0.37. And that's your other 0. And that's fine if the directions say to solve approximate. Approximate means decimal is okay. If the directions said solve exact, and you give me those 2 decimals, that would be wrong. Okay, decimals, unless it's a decimal that ends, like if you had the fraction 3/2, you can write that as 1.5. That is an exact decimal. But when you're solving a quadratic equation, a lot of times if you see these decimals, the only way to get it exact is with quadratic formula. So let's do the same problem again, but this time let's use quadratic formula. Just in case you see a problem on the test that says solve exact. What's A going to be? 2. B? 2. Also 2. And C? Negative 1. So we're going to fill in everything to the formula. Can somebody remind me first what the quadratic formula is? That we talked about it in an earlier section. Yep.
AX squared.
So not the form of a quadratic polynomial. That's the ax squared plus bx plus c. This is the formula that solves quadratic polynomial. Lucas?
Is it negative b plus minus the square root of b squared minus 4 times a times c divided by 2a?
Yep. So now we're going to fill in the a, the b, and the c, and I'm going to check and see if I get the same answers. Okay. So negative b is negative 2. B squared gives me 4. Then I have another 4 times a times c. A is 2. C is negative 1. And that's all divided by 2a, which in this case is 4. Okay. When we start to do this, we're going to be subtracting 4 times 2 times negative 1. That's negative 8. But when you subtract a negative, it becomes a positive. So the first thing I'm going to do is just eliminate my negatives because I know it's going to change to positive. All right, so that gives me negative 2 plus or minus 4 times 2 is 8. 8 plus 4 gives me 12. And sometimes when you get to quadratic formula, you get to that point, you are done. This one we're not because of the 12. 12 is a square root you can simplify. That's not part of quadratic formula. That's just part of like arithmetic with square roots. How can we break up the number 12 into two numbers, something times something, and one of them I can take the square root of in my head? 4 and 3. Yep. So let's break it up into 4 times 3, because 4 times 3 is 12. And what's the square root of 4? 2. So I get negative 2 plus or minus 2 root 3 over 4. And once we simplified that, look at every number that's not under the square root. They're all divisible by what? They're all divisible by 2. So then we can reduce that again. So if I divide negative 2 by 2, I get negative 1. What about if I divide 2 by 2? I get 1, so I just put that. And 4 divided by 2? 2. Those two answers that I just circled should be the same as what we got right there. How can I check that they are the same? Yeah, use our calculator. Let's type those in and see what happens. So negative 1 plus the square root of 3 divided by 2 is 0.36602. That's that. So there's my first answer. And now do negative 1 minus the square root of 3 divided by 2, and we get negative 1.366025 right there. There's your second answer. All right, so the difference between these two is this is an exact answer, that is an approximate answer. So if the directions say exact, you got to do something like that. Question on it?
Yeah, you got the same answers.
Mhm.
So what's the difference between approximate and exact?
Approximate is a decimal.
Oh, and that, okay. I see.
Yeah.
I thought we had to, for the exact, we had to write out the decimals.
No, if they ask for an exact answer, you would stop right there, and this is what you'd put on the test.
Okay.
You'd put negative 1 plus or minus root 3 over 2. If they ask for a decimal answer, then you could put whatever they ask you to round to, 0.366, something like that. Great. So any question on the difference between getting the exact answer and the approximate answer? I just changed the exact answer to a decimal to confirm it was the same. But normally we don't do that. Okay, so finding roots. Okay, when we find roots on the calculator, we just did it, but I want to write it down. Just gonna go like this. Okay, so to find roots graphically, so you put that down, and then use the root or the zero feature of the calculator. That's the second. I'll just tell you the buttons you press. So you press second, and then you press calc. And on my calculator, it is option 2. Yeah, option 2. If you're using a different kind of calculator, it's possible that can do the same thing. You might have to find where it is on your calculator. All right, let's try this one. Now, this one says solve approximately. I'm not even sure we could do this one exact with what we know right now. Why not? What makes this equation a little harder than the last one? Yeah.
Exponent of 3.
It has an exponent of 3. So you can't just plug that into quadratic formula. It's not quadratic. So is there a formula like the quadratic formula when the exponent is a 3? Yes, there is. Yeah. It's much longer than the quadratic formula. It's very long. So the cubic formula is generally not something that we learn. It's not something I've ever used. So when we talk about solving cubics and I ask for an exact answer, it's going to have to be a cubic where something nice happens. Okay? Like this very first problem we did, that's a very nice cubic problem. Because every answer that we got to that one was a nice number. A -1, a 2.5. So if the answers come out nice, then we can work with a cubic. If the answers don't, then we're going to just do it on the calculator. So what's my first step to solving that on the calculator?
Make it equal to 0.
Make it equal to 0. Yep, just like we did with the quadratic and the linear ones, you've got to make it equal to 0. And how would you make that equal to 0?
-1.
Yep.
Right side.
That's -1 from both sides. Okay, so that's a good first step. And what do we do now that it's equal to 0? Yeah, how do I put it in? Okay, go to y equals, clear anything that's there, and now type it in. So x cubed plus 2x minus 1. Okay, and because it's a cubic, we talked a little about what that 3 tells us. How many times could this graph cross the x-axis? It can turn twice, but it can cross up to 3 times. Right? Like the first cubic we did on the very first question, it crossed 3 times. So this could cross 3 times, and that would look something like this. It could cross 2 times, and that would look something like this. That's 2. Could also cross 1 time, and that could look something like that. Could it ever cross 0 times?
No.
No. A cubic has to always cross, because another thing we're going to learn about a cubic is one side of a cubic goes down forever, the other side of the cubic goes up forever. and it's connected the entire time. So if you go up to infinity and down to negative infinity, and you're connected the whole time, you're going to pass through 0 in just a second. You're going to have to cross through 0 at some point if you go up and down forever. So cubics always cross the x-axis at least one time. Maybe 2, maybe 3. Let's graph this one and see. So I'll do zoom 6. All right, and this is the kind of cubic that it starts to think it wants to turn a little bit, and then it never does. Okay? So that is a complete graph. So you're seeing everything you're going to see. Okay. So how many times does this one cross the x-axis? Yep, just once. How do I use the calculator to figure out approximately where it crosses?
Second trace.
Yep. We don't just want to say, oh, it looks like it's 0.5. I mean, maybe it's 0.5, maybe it's 0.47916. Who knows? So we want to do second calc 0 and figure it out. Okay, so pick a point somewhere to the left, somewhere to the right, and do the guess. And it crosses the x-axis at about 0.45 if we round to 2 decimal places. Any question on that? Okay. All right, so a couple things about third-degree polynomials. We've looked at them already a little bit, so we kind of know what they look like. That's the format of what a third-degree polynomial looks like. That would be the most complicated version you could have. The simplest version you could have is this. That's a third-degree polynomial as well. As long as the highest exponent is a 3, it's a third-degree polynomial. It doesn't have to have all these other ones. If it does have them, then it adds to the complexity of what it does. That's when it starts to do more of the turning. So these are all different types of cubics. Notice each one of them, on one side it goes down, and on the other side it goes up. This one is down on the left, up on the right. This one is up on the left, down on the right. So it's like a mirror image of it. The first two, they're the ones that never quite make that turn. They think about it, but they don't do it. And the two on the right, they actually make a full 2 turns. But a cubic has to turn either 0 times or 2 times. It can't turn 1 time. Because if it turned 1 time, a cubic can't keep heading down. This would be heading down on the left, and if it never turned again, it would just keep heading down on the right. That's a parabola. It's got to turn again to go back up. And it has to be a smooth turn. You can't, you never have like a sharp turn. Everything about it is a smooth curve. Any questions on the general look of a third-degree polynomial? Every time that this number goes up by 1, you increase the number of turns it could take. So if that number was a 4, it could turn 3 times. That's what a 4th degree could look like. And then a 5th degree can turn 4 times. So that could do something like this. So every time you add another exponent, it just adds a little bit of complexity to what it looks like. Okay, so here's a cubic. It's got every term in it, cubic, quadratic, linear, and constant. So it could mean that it's pretty complicated. It's got a lot going on. But we're not doing anything algebraic. It's already equal to 0. So that first step is done. What am I going to do to figure out how many solutions this has? Yeah, we're going to graph it. And when we graph it, it's equal to 0. So what are we looking for when we graph it? That's going to answer that question.
The x-intercept.
We're looking to see how many times it crosses the x-axis. And remember, those places where it crosses, those are called your roots. All right, so let's type all that in. So x cubed minus 5x squared plus 6x minus 1. I'll start with zoom 6, and we'll go from there. Okay, that's a good window. I can definitely see what's happening. There's nothing, nothing cut off. How many times, or how many solutions does that equation have? 3. Okay, I may not say on the test how many times does it cross the x-axis. You have to know that the solutions are where it crosses the x-axis. And now it says to find the middle one. When I say the middle one, I just mean this one. I'm not saying it's exactly in the middle, of these two. Maybe it is, maybe it isn't. I just mean find the answer that's between the two on the outside.
We can calculate this on the test.
Yeah. Yeah. But if you forgot how to calculate the root on the test, that's not something I would tell you. If something comes up that you've never seen, or it's something I think you wouldn't be able to fix on your own, then I'll fix it. Okay, so how do we find the answer that's in between the two on the outside? It's the one that I circled. Second, trace, option 2. And where do I put my cursor for this one?
Left of the middle.
Yep. Just make sure that it's only encompassing one of the intercepts at a time. So that's fine. And then where do I put it now?
To the right.
Yep, to the right. You would not want to go over here. That's too far. Now you're going to get 2 in the same interval. Okay, we just want 1. And then the last thing is the guess, which doesn't matter. So the middle root, if you were going to round to 2 decimal places, is 1.55. Okay. Any questions on that? So that is the homework for tonight. Okay, you've got a good amount of time today. You've got about 25 minutes. So please use the time to work on that. I will pause the video and I'll go put a list of topics that are going to be on the test. The review guide is going to cover that tomorrow as well. But I'll list out the topics here so you have them.